Hey everyone, welcome back to AI.Code.Cast. We're diving into a classic coding challenge today that contains duplicate problem. It's a favorite in coding interviews and a great way to test your understanding of algorithms and efficiency. How to make your code really hum.
It really gets to the heart of efficient searching and how seemingly small decisions you make as a programmer can dramatically impact performance, especially when you're dealing with mountains of data, like truly massive data sets.
So let's break it down. Imagine you have an array, which is just a collection of integers. Could be anything, right? From
Yeah.
just a handful of numbers to millions. The goal is to figure out as quickly as possible if any of these numbers appear more than once. So where do we even begin with something like this?
Well, the most intuitive approach is often the brute force method, kind of like
Yeah.
if you were looking for a document in a giant filing cabinet, you'd check every single drawer. It's guaranteed to find it if it's there. But it could take a while, especially if that filing cabinet is huge.
Okay, so we're essentially comparing each number in the array to every other number, just to see if there's a match. But I'm already sensing some drawbacks here. What are we sacrificing with this simplicity?
Efficiency, mainly. Imagine our array has like a million numbers. If we're comparing each number to every other number, we're potentially doing a trillion comparisons. A trillion! That's an insane amount of computational work, especially if we're working with limited resources or time.
Yeah, I can see how that would be a problem. So brute force is like, what, using a magnifying glass to find a needle in a haystack? Technically possible, but not exactly the most practical approach. What are some smarter ways to tackle this? I'm guessing this is where clever algorithms and data structures come into play, right?
Absolutely. And one technique that's often used for this kind of problem is sorting. What if we rearrange the numbers in our array from smallest to largest?
Sorting, okay. How does that help us figure out if there are duplicates faster?
Well, think about it this way. Once the array is sorted, any duplicate numbers are going to be right next to each other. So instead of comparing every number to every other number, we can simply walk through the array once, just checking if each number is the same as the one before it.
Oh, that makes sense. So by sorting the array, we basically eliminate the need for all those extra comparisons.
Yeah.
It's like organizing our haystack so all the similar pieces of hay are together, making the needle much easier to find.
Exactly. And there are some really efficient sorting algorithms out there, like one called heap sort. This can sort the array in a way that really reduces the number of operations, especially as the size of the array grows, compared to that brute force method we were talking about.
Okay, sorting definitely seems like a way more efficient approach, but I have this feeling that there might be even more elegant solutions out there. What else could we try?
Let's think about what we're really trying to do here. We want to know if there are any repeats, right? Not how many repeats or which numbers are repeated, just whether any number appears more than once. That's all we need.
Right, right. So is there a way to streamline the process even further? Maybe a data structure that's specifically designed for this kind of check? So we were talking about using a specific data structure, to solve our contains duplicate problem. What if we could store each number and instantly know if we've seen it before?
No, that's a great idea. And there's a data structure that's perfect for that, the hash set.
Hash sets, okay. Remind me how those work again.
Think of it like a super organized library. Each book has this unique call number, right? You can instantly locate any book if you know its call number, because there's only one copy.
So if we tried to add a duplicate book, it would be obvious, right? Because there's already a book with that call number.
Exactly. That's the beauty of hash sets. They're designed to store unique values and quickly tell us if a value already exists. So efficient.
Okay, I'm seeing how this could be helpful. So how would we use a hash set to find duplicates in our array of numbers?
Well, we could start with an empty hash set, and then we'd go through our array, one number at a time. For each number, we ask, is this number already in the hash set? If it is, boom, we found a duplicate. If not, we add it to the hash set and move on to the next number.
So it's like we're trying to add each number to our super organized library.
Yeah.
If it's already there, we know it's a duplicate. And since hash sets are designed for fast lookups, this seems way more efficient than comparing every number to every other number.
You got it. On average, this approach, using a hash set, lets us solve this problem, the contains duplicate problem, that is, with the time complexity of O(n), which basically means the time it takes grows linearly with the number of elements in our array. It's a massive improvement over that brute force approach, which, remember, has a time complexity of O(n).
This is so cool. We've gone from searching every drawer to organizing our haystack to now having this super organized library, and each step has made our solution more efficient. It's amazing.
It really shows how understanding different data structures and algorithms can make our code so much more efficient. It's like night and day. But here's the thing. There's another really elegant solution to this problem we haven't talked about yet.
Oh, there's more. I'm all ears.
Wow.
What's this other elegant approach?
It involves using sets and a little bit of a trick. Remember how sets, just like hash sets, only store unique values?
Yes, that was the whole reason we were using a hash set in the first place.
Right. So what if we took our original array of numbers and converted it into a set? What do you think would happen?
Well, if sets only store unique values, converting our array into a set would automatically remove any duplicates, wouldn't it?
Exactly. And here's the clever part. If we compare the length of the original array to the length of this new set we created, we instantly know if there were any duplicates in the original array.
Wait, I think I see what you mean. If the set is shorter than the original array, then some numbers must have been removed during the conversion, meaning there were duplicates.
You got it. It's so simple, but incredibly effective. A really cool way to solve the contains duplicate problem.
This is blowing my mind. We've gone from comparing every single number to using the unique properties of sets to instantly tell if there are duplicates. This is AI.Code.Cast at its best.
It really shows the power of understanding data structures and thinking outside the box. Sometimes the most elegant solutions are the ones that make the best use of the tools we already have.
Okay, we've explored a bunch of different ways to solve the contains duplicate problem. Before we wrap up this part of our deep dive, anything else our listeners should keep in mind when tackling this kind of problem?
Well, remember that there's rarely just one right way to solve a coding problem. The best approach really depends on a lot of factors, like how big is the input data? Are there any specific constraints in the problem? Even what programming language you're using, all these things matter.
That's a great point. So we need to consider the different options, weigh their pros and cons, and then choose what makes the most sense for our specific situation.
Absolutely. And you know what? In the next part of this deep dive, we'll discuss some potential pitfalls and best practices to help you avoid those common mistakes and write even better code.
Sounds great. Stay tuned, everyone, for the final part of our Contains Duplicate deep dive. We'll share some valuable insights that will help you take your coding skills to the next level. Welcome back, everyone, to AI.Code.Cast. For the final part of our deep dive into the Contains Duplicate problem, we've talked about some pretty clever solutions, like sorting, hash sets, even some set magic to find those pesky duplicates. But like with any coding challenge, there are always some traps we got to watch out for.
Right, absolutely. Even the most, elegant solutions can have these little details that can really trip us up if we're not careful.
Yeah.
It's all about paying attention to the fine print.
So what are some common traps that coders fall into when tackling this problem? What should we be on the lookout for?
One common mistake, especially when you're just starting out, is forgetting to handle those edge cases, those weird scenarios that can pop up.
Edge cases. Can you give us an example?
Sure. Like, let's say we're using that brute force approach with nested loops to compare every number in the array to every other number. What happens if the array is empty?
Ah, right. The code might try to access elements that aren't even there, causing an error. Got to think about those empty arrays.
Exactly. So it's super important to think about those edge cases like empty arrays or arrays with just one element or arrays with just one element and add checks in our code to handle them gracefully. You don't want your code to crash unexpectedly.
So it's like adding safety nets to our code to prevent those crashes. Makes sense. Any other pitfalls we should be aware of?
Well, another one to watch out for is with the sorting approach. Remember, sorting changes the order of elements in the array. It doesn't keep the original order.
Yeah, we talked about that. If we need to preserve that original order, for whatever reason, got to make a copy of the array before sorting it. Can't mess with the original.
Exactly. Simple step. But it can prevent a lot of headaches down the line, trust me.
Always be mindful of the original array, then, when using sorting. Okay, what about the hash set approach? Any pitfalls specific to that method?
Well, one thing to consider is those hash collisions. Remember those?
Hash collisions. Remind me what those are again.
Sure. A hash collision is when two different elements in the array, by pure chance, end up with the same hash value, meaning they'd get assigned to the same spot in the hash set. It's like a cosmic coincidence.
Ah, right. So even though hash sets are great for fast lookups, Collisions could slow things down, huh?
Yeah, in the worst case scenario, if there are tons of collisions, the performance of the hash set approach could really suffer, especially with huge data sets or if your data is prone to collisions, something to keep in mind.
So hash collisions are like having two books with the same call number.
Right.
And our super organized library could cause some mix-ups and slow down our search.
Exactly. But hey, most programming languages use well-designed hash functions to minimize those collisions. But still, something to be aware of, just in case.
Great points. So we've covered some important pitfalls: edge cases, modifying the original array, and hash collisions. Any other golden nuggets of wisdom to help us write better code for this problem? Or just in general, level up our game?
Of course. One of the most valuable things, honestly, is to write code that's clear and concise. Use names for variables that actually make sense. Add comments to explain your logic. Avoid making things more complex than they need to be. Keep it simple.
It's like writing a good story, right? Your code should be easy to follow, understand. And if someone else needs to work on it later, they won't want to pull their hair out.
Exactly. And testing, don't forget testing. Create all sorts of test cases, including those edge cases we discussed. Make sure your code can handle them all without breaking a sweat.
Testing is like having a safety net, for sure. Catches those bugs before they can cause trouble in the real world. Essential stuff.
Absolutely. And, don't be afraid to refactor your code. As you gain experience, you'll find better ways to solve problems. Write more efficient code, more elegant code. Refactoring is just part of the process.
It's like editing a book, right? Always room for improvement. Maybe you can make it flow better, be clear, have a bigger impact.
Exactly. So, let's recap. Always consider those edge cases. Be mindful of the original array. Watch out for those hash collisions. Write clean, beautiful code. Test, test, test. And never be afraid to refactor. Those are the keys to success.
Wow, I feel like a coding ninja now.
I'm glad to hear that. And remember, the more you practice, the better you'll get at spotting patterns, choosing the right approach, writing clean, efficient code. It's a journey.
Thanks for all the awesome insights. This has been another fantastic deep dive here on AI.Code.Cast. I can't wait for the next challenge.
Me too. Until then, everyone, happy coding.